11.2. So today I am going to share with you how you can evaluate limits without the use of a calculator. Okay? Last class I allowed you to use a calculator for two reasons. One, you could graph, and two, you could use a table. Right? By now, you know what a limit is.
Yeah.
And if I give you a calculator, all you're going to do every single time is graph it, and then it's very obvious. Agreed? So now I'm going to show you how to do this without a calculator.
Great.
Okay? Whatever we do today, if any of these techniques fail, what do you think you can still do?
Cry.
Not cry.
Give up.
Don't give up.
There's no sequence.
Not B&E.
Intermediate value theorem.
YouTube, this is really high school. We're all a bunch of kids. Yeah. Okay? We don't have a calculator, but you can do what the calculator will do for you. You plug in values for what? You can make a table or you can make a graph. If anything that I show you today fails and you can't figure it out algebraically, you still have two things to rely on, which is graphing, which I sure hope that you know how to graph by now. And number two, make a table. Okay?
Wait,
here we go.
This is non-calculator, right?
Yeah.
The test is the last week of school.
Woohoo!
Here we go. Problem number one. Both of these problems, I think I gave them to you last class, and you used the calculator for them, and you were able to find the limit. So you already know the answers for them. Okay? The answer for the first one was 6, and the answer for the second one was 0.889. You did both of these problems in class last time. Now we are going to do both of these problems without the use of a calculator. Okay? Any thoughts? Factor it. Good. On the first one, we are going to factor out the expression to become the limit as x approaches 3 of what? X plus 3 times x minus 3 divided by x minus 3. Agreed? It is very obvious at this point that something is canceling away, and you should be very happy. Every time you have a limit, from the beginning, when you plug in the value, it causes the denominator to be equal to 0. You need to manipulate it algebraically in a way that you can cancel out what's giving you a problem, which now we did. What does that tell you about the graph? We don't have to graph it, but what does that tell you? It has the whole. Now, we've already talked about limits and discontinuities. Having a removable discontinuity, does that affect the limit whatsoever? No. You can still have a limit exist there. What type of discontinuity could you not have a limit exist there?
Jump and infinite.
Jump.
Or not infinite.
Not necessarily infinite, right? Just jump. You are guaranteed 100% of the time that if it's a jump discontinuity, it's just not going to happen for the limit, right? So what's the limit for this one?
6.
6. Because once you cancel out, you're going to just plug in the value. 3 plus 3 is 6. Do you guys notice that that's actually how you find a whole? Do you guys remember?
Yeah.
After you cancel out, you solve for 0, right? And then you plug in. The limit will be at the location of the whole. Sweet? All right. Number 2. What do you think I need to do?
Factor.
You need a factor. Okay? Now, I wanted to show you something on this problem. The first thing you should always try to do when you try a limit is plug in first. Because if you plug in and you get an answer, you're done. You're not wasting time trying to figure out any other techniques. Okay? Now, I'm going to save some time, and I'm going to tell you that when I plug in 2, the numerator is 0. And when I plug in 2, the denominator is 0. Okay. Here, this actually has a name when you get 0 over 0. And it's quite important, so I need you to write it down. When you get a limit in which you have 0 over 0, that is known as the indeterminate form. You're not going to understand why I want you to memorize this, because I know a little bit of calculus, so anytime I get the indeterminate form, I'm very happy. Because when it's indeterminate form, I will teach you this later on. There's a shortcut where I can tell you the answer right away. But I'm not going to teach you the shortcut until you learn how to do limits. Okay? So the indeterminate form, anytime you see it, you're going to find out very soon. You're happy, because you're going to know the answer right away. Okay? So here we go. We don't know the shortcut yet, so then you are going to try to factor out this expression. Okay? So, can we factor this out?
Yeah, the top goes.
I sure hope so.
X squared minus 2, or sorry, let me.
Oh no, I ran out of ink.
Oh!
It didn't make it though. It went in the corner.
No, it made it. Believe. If you believe.
LeBron.
As x approaches 2. Alright,
Look, Harry,
I am going to try to use group in here, and so should you. So, on the numerator, if you group them, what does this set of parentheses have in common? X squared. And what would you be left with?
X minus 2.
So I know that for sure has to be one of the factors, right? How can I achieve having x minus 2 here?
Negative 4, take it out.
So
Or
that
positive 4, take it out.
negative 4, right?
Wait, no, it's
Oh, it is a positive. I'm sorry. Good catch. Cool. What about the denominator? Well, if I group those two, what do they have in common? An x cubed.
And then that was just plus 1.
Agreed? It is at this moment, one more time, you should be very relieved. Because when you look at it this way, do you see how this factor right here is what's going to give you a problem?
Yeah.
Because when you plug in 2, that would give you a 0. We want to get rid of things that gives us a problem. Luckily for you, you don't really have to do much at this point because it's already there. It's going to go away. There's a hole. Okay? Now, what are you going to try to do to find the limit?
Plug in.
Plug in. If it works, great. If it doesn't, then you have to continue to manipulate this. So we're going to plug in 2 squared is
4,
plus 4,
8,
8. 2 to the third power is
8,
plus 1.
9.
8 over 9 is equal to 0.88888888888 forever. And notice that last time we found the answer to be 0.889 with the calculator. Okay? Alright, so you've learned a new technique. Now you have 3 per se. Number 1 was if you have the graph, a table. Now you know that if you use factoring and you're able to cancel out terms, you can then simply plug in and find the limit. Okay.
Yep.
Yes? Sweet. Number 2, here's your second technique, which is rationalizing. Rationalizing means to multiply by the conjugate. Oh, conjugate. Do you guys remember what a conjugate is?
It's like if it is x minus y, it's x plus y.
So it's when you switch the sign that's in between the two expressions. You are going to multiply by the conjugate to rationalize either the numerator or the denominator. What do I have to rationalize on this problem?
Numerator.
Why the numerator?
Because it's irrational.
That's where you have the, anywhere where you have the root, on this problem it just happens to be on the numerator, okay? It doesn't have to be on the numerator, it could be on the denominator. So in order for me to rationalize this, I need to multiply by
Square root x plus 2.
both top and bottom of the fractions, so the numerator and the denominator. Okay. It's okay though. Yep. Look, here's the reason why I have to rationalize, so let me make sure you understand why. I'm looking for the limit as x approaches 4. So the first thing you do with a limit is plug in to see if it works, right? Square root of 4 is 2, minus 2 is 0. But more importantly, 4 minus 4 is 0. Indeterminate form one more time, right? Now, that should give you a hint. First of all, we can plug in. Then the second thing that you know how to do is to factor, but there's nothing to factor, right? So now I'm going to try this rationalizing technique, okay? And I agree, we are going to be left with a root on the denominator, but, so square root of x times square root of x is,
X.
so we have the limit as x approaches 4 of x. Square root of x times 2 is 2 square root of x, and negative 2 times square root of x is negative 2 square root of x, which cancels away. If you remember, every conjugate does that, so don't even waste your time multiplying those out. But what is negative 2 times positive 2? Negative 4. Okay. Now here's where I want to make sure, you know how I always tell you simplify? Here's where I'm going to tell you do not simplify. Here's the reason why. X minus 4 times square root of x plus 2. Look the way I wrote it. Can you see something? It cancels out. But if you multiply it in, you're not going to see it. And you're just going to get stuck. So do not multiply it in. When you are rationalizing, I repeat, when you are rationalizing the expression, do not actually multiply in the other part. So in this case, this cancels out, leaving you with 1 over that. It's okay that you have a root on the denominator. Okay, so now you're going to check to see if it works. What is the square root of 4? 2. Very good. Thank you for bringing that up. Plus or minus 2. But be careful. So check this out. If the square root of 4 is plus or minus 2, it's very obvious one of those is not going to work. Which one?
The negative one.
Negative 2. Oh, the negative. Okay, I thought negative 1. Okay, all right. The negative 1, right? So the negative 2 will not work because that will make a denominator 0. So we don't need to worry about that. As a matter of fact, when you're doing limits, you don't have to worry about the negative roots. Okay? So it's going to become, what's the answer?
1 over 4.
1/4. Oh, sorry. Okay, another technique then. We have graphing, table, factoring, rationalizing. Okay? The last one is your good old friend algebra. And I'm not going to help you with this one. So if you're watching the video, go ahead and pause it. Try this on your own. And when you're ready, just press play and look at the answer.
I believe in you.
Thank you. All right, here we go. The first thing that you should have attempted to do, and there's several methods of doing this. It all depends on what your brain tells you to do, but it's essentially the same kind of step, which was I wanted to combine these two fractions on the top. So in order to do that, I need common denominators, which in this case will be to multiply 4 times x plus 2. But I didn't actually multiply them. I just left them without distributing. To do that, then you would have to multiply this first fraction by 4, and that's how I achieved getting this 4. And then this second fraction by the x plus 2. Here it is, and there's your minus signs, right? So you have this is your numerator divided by that. I simplified the 4 minus x plus 2, distributing in the negative, and you have negative x plus 2 over this. That's your top fraction divided by x minus 2, right? You want to keep this top fraction, and I went ahead and did an extra step. I don't really like having that negative in front, so I factor out a negative 1, and it changed into x minus 2. And as soon as I saw that, I was like, I need to get rid of the x minus 2. I'm on the right track, right? When you are dividing a fraction by anything, you're going to keep the fraction, which I did, and you are going to flip the bottom, in this case, expression. If you flip that as it currently is written, I know it's not written there, but technically right now you have x minus 2 over 1. Anytime you have any number and you want to make it into a fraction, you make it over 1. If you're going to flip that, then you get 1 over x minus 2. The x minus 2 cancels away, leaving you with negative 1 times 1, which is negative 1. And 4x plus 2, again, I didn't really multiply it out. You can if you want to, but not necessary. And then I plugged in 2. 2 plus 2 is 4. 4 times 4 is 16. Negative 1 over 16. Okay? Your algebra skills are going to come into play. So, practice. That's pretty much all I can tell you. Okay? There is a reason why on this test that we just took, I don't just throw out things just because, right? I had you practice simplifying expressions quite a bit, right? There's a reason for it. Here it is. Okay? 3 new techniques you've learned today. You're going to plug in. If that fails, you're going to try what? Factoring. If that's not possible, you got to look if you can rationalize. And if none of those work, what can you do? Graph it or make a table. Don't forget about what I taught you the first day, right? It's still a possibility to use that to find a limit. Are we good? Yes? Alright, so then moving on. I have to add another definition for you. One-sided limit. I understand, you understand now what a limit is. You understand the calculus of it, right? What's a limit? What's happening is what? As you approach from both sides, either side. Remember, that's what the definition says? You're approaching from either side. What do you think a one-sided limit is? As you approach it from what? One side. Alright, before I actually give you an example of this, I want you to think this through. Okay? Is there such scenarios where you would have no limit existing? Yes? Give me an example. What kind of discontinuity? Jump. We know for sure, 100% sure, every single time you have some kind of function in which you have a jump discontinuity, the limit is not going to exist. Now here's my question to you. The limit is not going to exist, but do you think it will have a one-sided limit?
Because it reaches one point and then it's
We'll find out. So here we go. You have this function right here, limit as x approaches 0 of the absolute value of x over x. Okay? If you plug in, it's not going to work, right? There's nothing we can factor, and there's nothing to rationalize. So what are you going to have to do? Graph. I need to know what this looks like. F of x. I need to know what that looks like. Well, back in, for a lot of you guys, was 7th grade. For some of you guys, was 8th grade. For some of you guys, maybe 9th grade. You learn how to graph. I'm asking you to go that all the way back to when you first learned how to graph. What did you do? Just plug in values, right? I know for sure I cannot be at 0. I can't plug in 0. Agreed? Which means, what do I have at 0, by the way? I have a rational function. What do I have? Not a whole. I have a we have an asymptote. Set the denominator equal to 0. Okay. Alright. I can't be at 0. Why is this not a whole? You're not canceling anything out, right? Okay, so now, you can't plug in 0, but you can plug in anything else, right? What do you guys want to start with? 1. Absolute value of 1 divided by 1. Absolute value of 2 divided by 2. Absolute value of 3 divided by 3. Do you get what's happening? What does this look like? A horizontal line at 1, right? Here's my question. But what about anything between 0 and 1? Would it also be 1? Yeah. Do you guys all agree? Absolute value of 1/2. 1/2 divided by 1/2. So it is 1, right? But can you be at 0? No. Now, this is not representing a whole. This is just so that you can see that you cannot be there. Okay? We understand? Now, what about -1? Over -1? So you're down here, right? -2. 2 divided by -2. -1. -3 is 3 divided by -3. So then, would you agree that this thing looks like that? Yeah. You can be there, right? Okay, you have the graph. Now, I know for all of you, since it's on the project, can't really see the print, so let me make sure I kind of... It seems like I'm asking you the same question 3 times, right? Yeah. Okay. The very first one, okay? It has a little negative sign here. Right? It looks like a power. It's not a power, it has a little negative sign. What this means is this is asking you, hey, what is the limit as x approaches 0 from the negative numbers? Which in this case is the left, right? Negative numbers are to the left. So if you're approaching 0 from the left, what value did you approach? -1. It's the y value, remember? You're looking at the output. Agreed? Yes.
So would there be a positive sign or one departing from the right?
Good. So that's the next one. And I know you can't see it, but right here you have a little plus sign. What that means is from the right. What happens as you're approaching 0 from the right? So from the right, I am approaching what value? 1. Agreed? Now, the last one doesn't even have a symbol. So what am I asking you? From both sides. Limits like you have been doing them till now. What is the limit as x approaches 0 of this thing? Does not exist.
So if the limit from one side is not equal to one from the other side, it's not.
So, there's a reason for this types of limits. So I want to improve the definition that we have. You keep saying a limit is when I approach the same value from both sides. Let's improve that with what you know now. In order for a limit, so this third one right here, in order for this to exist, what can you tell me about their one-sided limits?
It has to approach the same value.
Good. Give me a sentence that I can write for a new definition. For a limit to exist, what?
Both one-sided limits must be equal.
For a limit to exist, what?
Both one-sided.
You wouldn't say both. Just say one-sided. We're good? We understand. One-sided means either left or right. The one-sided limits what? I like that word. They must. You don't have an option. They have to be equal. I'm no longer going to use the word left, right. I'm going to use the word one-sided limits. Understood?
Yeah.
On the test, you have to be very careful. Okay, I know you can't see it because it's not in front of you. But if I ask you for a limit, and it has a little plus or a minus sign, you should be looking for a one-sided limit. If you find the actual limit, you're going to get it wrong.
Will you supply magnifying glasses?
No. Okay. Number 5, right here. I want to see if you truly understand
Oh gosh.
the following. Okay? So, if you're watching the video, let me try to zoom in a little. That's the best I can do for you. The rest of you, I want you to try this on your own. So if you're watching the video, try this on your own. The rest of you, I want you to do the same. I'm going to project the actual digital version here in just a second so you can see it better. Okay? Alright, so if you were watching the video, the answer for each one of this is 1. You do not need to graph this. When this is approaching from the left, you need to be using the top part of this piecewise function. So when you plug in, you get 1. When it's approaching from the right, you should be using the bottom part of the piecewise function, which is also 1. Remember that when the left and the right-hand side limits are exactly the same, that means that the actual limit does exist. Okay? Moving on. I trust your algebra skills, so one more time, I am not going to demonstrate how to do this problem. Okay? So if you're watching the video, take a look at the problem and try it on your own. Here is what is given to you. You are given a function, and you are told to find the following limits. So if you're watching the video, go ahead and pause this. If you're in class, I will put up the digital version here in just a second. Here we go. This is the last thing we're doing. I'm bringing trigonometric back. Okay? Alright. All of these limits, like look at these limits. None of the limits that you have here, if you just plug in, you're not going to be able to solve. You're going to get 0 in the denominator. Okay?
Every time.
And there is nothing you can do for most of this algebraically with the skills that you have at the moment to solve them. Eventually, you are going to be able to solve those. Okay? Eventually, you are without the help of what I'm going to give you. I am going to give you some information to begin in order for you to solve this problem. Guess what? You need to memorize the information that I'm giving you up top. Okay? These two limits you need to memorize. So you need to memorize the fact that the limit as x approaches 0 of sine of x over x is equal to 1. And you need to memorize that the limit as x approaches 0 of cosine x minus 1 over x is equal to 0. No, these are not identities. No, there is an actual way of solving this. You just don't have the skills yet. Okay? But I'm giving you this information so that you can solve the limits. Keep in mind, do you guys remember those properties that I showed you at the beginning? Right at the beginning of the lesson.
Oh, yeah, okay. Yeah. I thought you
If you can use those properties with this, you're going to be golden. Okay? I'm going to give you one example, and then you're going to try the rest on your own. Okay? So the very first problem, I have the limit as x approaches 0 of sine square x divided by x. I am going to rewrite that limit. I'm going to rewrite it in a way that I can get sine x over x. So what I'm going to do is I'm going to say, hey, the limit as x approaches 0 of sine x over x, what do I need to multiply this by so I can get sine square x over x? Agreed? If I do this times that, I get this. Agreed? And the product properties tells you that you can find the limit of each one of these individually and then multiply them, right? What is the limit as x approaches 0 of sine x over x? 1. Agreed? What is the limit as x approaches 0 of sine of x? Is sine of x continuous? Yes. Can you plug in? What's the sine of 0? So what is the limit? 1 times 0 is? Bingo. Because it's continuous. Yep. All right. The rest of this, I'm sorry? Not necessarily. There are parts where the function is continuous. It wouldn't work where it's discontinuous. Where is tangent discontinuous? Pi over 2, so that wouldn't work. But if I say add pi, it'll be continuous. See what I'm saying? All right. Your job, you have until the end of class, and you have to show me the answers, is to figure out what number 2, 3, 4, and 5 is. If you are watching this video, this is where it will be ending. If you want to find out the answers, look up at the Learning Hub. Thank you for your attention.